Hi everybody, I'm going to give you a little more guidance in terms of your assignment for the week. There's a few things that it looks like some folks are still confused about based on your discussion questions, so I wanted to reiterate and try to reinforce some of the ideas that I made comments on in some of your posts. So I have a different data set that I just kind of made up that's fairly similar to the one that you're going to use for your assignment. And in this case, instead of a pretest and a post-test like you have on your assignment, this is weight 1 and weight 2. So imagine it's a weight loss program. We have a measure of weight at the beginning and a measure at the end, weight 1 and weight 2. We want to know if our program works for these people, if there's a difference in weights at these two different times. So we could say we're looking for the effect of time on weight, but we think there's no time variable here. What does that mean? So really what we're doing when we think about an independent variable is our weight at time 1 is independent. We're not doing anything that's impacting that number. That weight at time 1 doesn't have, we're not doing anything that's going to change that. Weight at time 2 is dependent on what we've done in our experiment, and also probably dependent on the weight at time 1. So our independent variable is the time 1 measure, and our dependent variable is the time 2 measure. Okay, let's talk about our hypotheses. So before we even look at any results, we need to be clear about what our hypotheses are, because what we're testing is those hypotheses. So our null hypothesis is always that there is no difference. The difference is null, or you can think of it as there's no effect of the thing we're studying. So the null is always going to be that the two means are equal, because if there's no effect, or if the difference is 0 or null, the means will be equal. So mean 1 equals mean 2 is always our null hypothesis, and that's what's really being tested by all these statistics. Our alternative hypothesis is that they are not the same, but that's not actually what we're testing. We're testing the null, that the two means are equal. So let's look at our results and see how that plays out. So for our paired sample t-test, which is what we ran to do for this kind of analysis where we have the same person measured twice, our output looks like this. We're still going to look at our t-statistic and report that with the degrees of freedom, and then the significance test. So in this case, it's 0.000. It only reports out to 3 decimal points. It's probably 0.00531. Don't report that it actually equals 0. Say that p is less than 0.001 if this is a result that we have, and actually, frankly, I can't remember. Because it's not actually equal to 0, it's just very small. But let's talk about what that means. So your significance is the probability that your null hypothesis is true. So our null hypothesis is that the means are equal. What's the probability that that is true? It is less than 0.001. So there's a very small, tiny probability that these means are equal. So we say that this is a significant result and that it is likely that the means are not equal, that there's a difference between our means and the population. Now, can we ever be absolutely sure that there's a difference? No, there's still that teeny tiny probability that they're equal and there's no difference. But we are going to go with the probability that there is a difference. So that significance level right here, that's what's going to tell us if they're different or not. We can't just look at the means and say, oh yeah, that's a pretty big difference right there. They must be different, because it depends how many there are, how big the sample is, what the standard deviation is, what the mean is. So this is taking all that into account. So that's the number you need to look at. So that's the first piece of evidence. The second piece of evidence is your confidence interval. So that's going to be right here. So this is a confidence interval of the difference. What difference are you thinking? If we subtract 251 minus 222, we get what, 39, 38 point something? So no, 29 or 28 point something. So that's our difference in our sample. But if we want to be 95% confident that we have the true difference in the population, we're going to have a range. So we are 95% confident that the true difference in the population is somewhere between 18 and 38. Now, does that include 0? No. So we're 95% confident that the true difference in the population is not 0. 0 is not in here, which is why if one's negative and one's positive, then we're likely to say it could be 0, and that would mean the means are the same. In this case, it does not include 0, so that means we're pretty sure, again, that these means are different. The difference is not 0, the difference is bigger than that. So this is our second piece of evidence that, in fact, these two means are different in the population. So our conclusion from these pieces of evidence is, again, that the pre-test, the pre-weight, is different than the post-weight. So that is based on these findings. Again, not kind of eyeballing what that difference is. So that's what you're going to want to say in your conclusion. There is a statistically significant difference in the pre-test weight, mean equals blah, 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 and the post-test weight, mean equals 222, etc. So that's what's the kind of thing that you're going to be looking for in the kind of analysis and how to look at this output. So I hope that's helpful and helps, again, kind of solidify things for you. Please ask if you have questions. Thanks.